Okay, let us discuss question number 4. That is from chapter 9, simple harmonic motion. So let us understand the question first. A spring is mounted horizontally. So we have horizontal spring, okay, with its right end held stationary. So the right end, okay, and a 0.4 kilogram body is attached to the left end. Make sure we always draw the situation so that it will help us to solve the question. So we have right end. So this is our spring and a body is attached at the left side of the spring. So this is our body. Okay, this is our body. So this is how you can imagine the condition. The body is freely oscillating with a period of 0.5 second and the maximum displacement of 0.2 meter. So in this question, we have the information of mass, km, period, t, okay, and also maximum displacement, so S maximum. Okay, the first question is to find the spring constant k. Okay, we want to find k. And we want to find the angular frequency for the second question. Okay, we want to find omega. And the last one, we're going to find out the equation for motion of body, which means that we want to find out the equation of simple harmonic motion with the general form of x equal to a sine omega t. Okay, let us find the spring constant k first. So k can be found out from the equation of period because we have the information of period. Period is equal to 2 pi square root mass over k. Okay, so we substitute all the values. So 2 pi, our m is 0.4, and finally you'll get k is equal to 63.2 Newton per meter. And number 2, we want to find out the omega. Okay, so omega can be found out from the equation of omega is equal to 2 pi over period. So we have the period, so it's 2 pi over 0.5, and your omega is equal to 12.57 radian per second. Okay, this is the unit for omega. And the last one, okay, the third question, we're going to write down the equation of motion. So x is equal to a sine omega t. So make sure for this kind of question, we only substitute the value of a and also omega. Okay, so it has been mentioned in the question that the maximum displacement is known as amplitude. So it is equal to 0.02 meter. And omega, we have found it from the previous question, 12.57 radian per second. So now we can write down our equation of motion. This is x is equal to 0.02 sine 12.57 t. Okay, so that is your equation of motion of the body. Okay, and please write down where x is in meter and t is in seconds. So that's how we solve this kind of question.